Okay, let me just give you this first video with a little bit of background knowledge. You don't have to write any of this stuff down. I just want you to listen and think. Okay? Let's start with the basics. If I give you the problem 5 equals x plus 3, I'm confident that all of you would know that x is equal to 2. Okay? Now, if I asked you to graph that solution, we would just make a little number line, 0, 1, 2, and we would just put one dot right on the number 2, which means there's only one solution to this problem. Okay? The only answer you can possibly put in for this x is 2. Not a whole lot different from grade school when the problem looked like this. And we all wrote 2 in the box. Okay? One answer, and that's it. Alright, so then we moved on in high school and we started to do problems with inequality signs. And we said 5 is greater than x plus 3. And I'm pretty confident again that most of you would tell me that 2 is greater than x. And we liked the letter on the left, so we wanted it to point at the x, so we would say x is less than 2. So if I asked you what numbers work for these answers, people would start listing things like 1, 0, -1, -2, -3, and keep going down. So if I ask you to graph that solution set, we would say 2 doesn't work, so we'll put an open circle on it, but then we want to shade everything less than 2, and all those numbers will work. So what we should recognize here is that not only these whole numbers work, but a number like 1/2 is an answer. A number like -2.5 or -2 1/3. There's a whole bunch of answers to this problem. Okay? So we need to remember that we have multiple solutions. In order to represent multiple solutions, we use a graph to show that. Okay, so we should be really good at all of that at this point. Alright, so moving on, what happens if I say y is equal to x plus 3? So now instead of putting a 5 over there, I'm going to say y. So at this point, we don't really know what y will be. It'll depend on what x is. So while our solutions now are combinations of x and y that work. So what are some combinations that work? Well, if we let x equal 2, then we would know y is equal to 5. If I say x is 1, then if we put 1 in here, we would know that y is equal to 4. Okay? If x is -10, y would be -7. So we could go on forever. I don't have to use whole numbers. If I put 1.5 in there, then y would be 4.5. So not only do we have all these whole number combinations, but we would also be able to put fractions, decimals, anything. So once again, we've got many possible solutions. So if you have many possible solutions, you need to be able to graph those solutions. Okay? Well, in order to graph all these solutions, they have x's and y's in them. So it's no longer good enough to just have a number line. We have to have the coordinate plane. So we need an x-axis and a y-axis. So if we put in x is 2, y is 5. So 2, 5 works. 1, 4 works. I don't really have room to do -10. So I'll do 1.5, 4.5 works. And what you'll see is that you'll start to create numbers all along a line. So if we connect all those dots, we would get all of these answers. And what it means is the line represents all possible solutions. So if we went to this line and we put a dot right here, I have no idea, because this is not real graph paper, how far over and how far up that is, but whatever it is, that X number here and that Y number here would be, if I took the X number and added 3 to it, it would give me this Y number. It means that's a solution to a possible solution to this problem. So that's what graphing a line means, is we're trying to find all possible solutions to a problem. Because there's so many, you can't sit here all day and list them, then they want you to use a line to graph them. Now in grade school, we would have used those T-charts, and we would have said, okay, 2, 5, 1, 4, -10, -7. Yesterday, we would have said, okay, let's call this f of x, and if I put 2 in, what comes out? 5. If I put 1 in, what comes out? 4. So all of these things are all doing the exact same thing. They're finding all of the points, or actually they're finding a few of the points on this line. Once I have a few of the points, I just graph the line. Now I have a representation of all of the points on the line that make this true. And that's the reason that we graph lines. If you don't know the reason why, then you're just memorizing a process to do something. Okay? You need to understand why you want to graph a line. You want to graph a line so you can say, okay, up here, way up here, is this a solution? Well, I think it probably is, because if my line keeps going, I'm pretty confident it probably goes through that spot. But this point right here, is it a solution? Does this X combination and this Y combination work in this problem? No, they don't work in that problem. It's not on that line. So it's important to know why you're trying to graph lines. So in the next video, we're going to talk about 2 different ways to graph lines.